Hey guys, welcome to lesson 3.2.4, day 1. We are going to learn how to add and subtract rational expressions today, kind of just switch gears from the multiplication and division that we've been doing. We will go ahead and start with some simple fractions, and then we will work our way up to the rational expressions that we're going to be focusing on for this unit. So hopefully from when you learned how to add and subtract fractions for the first time, you remember that it's very important to have common denominators. And what that means is the numbers on the bottom of your fractions that you're adding or subtracting have to be the same. So in this case, this first example, they already have common denominators because they're both 5. So because that's the case, we don't have to do any extra work when we're adding. We can just go ahead and add the tops. And 2 plus 7 is going to equal 9. And then when you're adding fractions, once you have your common denominator, you don't add those as well. You just keep the denominator as is. Okay, and the reason for that, just for a little brief explanation, you can imagine that you're sharing like 8 cookies with your friend, right? If you were to eat 3 out of the 8 cookies, and your friend was to eat 2 out of the 8 cookies, then collectively together, you guys would have consumed a total of 5 out of the original 8 cookies, right? It would not make sense to say that you guys consumed 5 out of 16 because there was only 8 cookies, right? You can't just magically say 16. So it would make sense to say that, okay, 3 out of 8 plus 2 out of 8 equals a total of 5 out of 8. Okay, we're always working out of a whole. So when you're comparing fractions, you have to work with the same kind of whole. All right, so let's work with another one. Here's another very basic example where we can just go ahead and add because the denominators are already the same. So 2 plus 7 is 9, and then the denominator will just be x. All right, moving on to something slightly more complicated. 3/4 minus 2/5. So here we don't have common denominators, and so we're going to have to do a little bit of surgery in order to make the denominators the same. So the most foolproof way of doing that is just to use each other. Here in this fraction, if I want to manipulate it, I can just go ahead and use this denominator and multiply both the top and the bottom by it. Okay, and just like that, I'm going to take the other denominator and multiply the right side fraction by it on the top and the bottom. Okay, so by doing this, I will get a denominator of 5 times 4 on both sides. And so when we multiply, as we learned previously, we could just go right across. So 5 times 3 is 15, 5 times 4 is 20. So this fraction becomes 15 out of 20. And then this fraction becomes 2 times 4 is 8, 5 times 4 is 20. So now I can just go ahead and do the subtraction by doing 15 minus 8, which is 7, and the 20, the denominator, we just leave it as is. All right. So on to the next. There are many different scenarios when you're adding and subtracting fractions. So in this case, we don't have to change both the fractions like we did here, right? In this case, we have a denominator of x, and this fraction has a denominator of 3x. So really, since they both have something in common, we can get by with just changing this fraction and making it match this one. So if we just were to give this one a 3, we would have a 3x on the top and bottom. So let's go ahead and multiply both by 3. All right, so 3 times 3 is 9. 3 times x is 3x, which is the denominator we wanted. And then over here, we're just going to leave it the same because it already had the 3x that we were aiming for. So now we can go ahead and just do regular addition. 9 plus 2 is 11. 3x is the denominator. And that's our answer. All right. Okay, this one's slightly more difficult. It's a little bit more involved, but the process is the same. So here we have a denominator of x, and then here we have a denominator of x times x plus 1. So if only this fraction could have a denominator of x and x plus 1 too, since it already has an x. So what we can do is just multiply this fraction by what it's missing. It has an x, just like this one, but it's missing an x plus 1. So all we have to do is multiply the top and bottom by x plus 1. Okay, and that's going to give us 3 times x plus 1 on the top. And on the bottom, we will have x times x plus 1. So that's what our left fraction turns into. On the right, it's not going to change because just like the last problem, it already has everything it needed. All right, so now we can go ahead and do the addition and just turn this into one fraction. So we get 3 times x plus 1 plus 2 all over the common denominator. Even though this looks a little different because there's so many x's, there's parentheses, don't get tricked by that. It works exactly the same as these simpler problems that we did above. Okay, now that we did this, we want to go ahead and do some simplifying. In multiplication and division, I specifically told you guys not to worry about multiplying things out. In addition and subtraction, you actually do want to multiply things out, just on the top, because there's going to be a lot of combining like terms going on. So 3x plus 3 is what I get when I distribute that 3 in there. And then I have a plus 2 chilling on the outside. The bottom can just stay x times x plus 1. And we can do one more step here. We can combine the 3 and the 2 because those are like terms. So this gives us a final answer of 3x plus 5 because 3 plus 2 is 5. And then the denominator, again, does not change. So this is our final simplified answer. Okay, and if we were to find excluded values, we would use the parts of the common denominator. So if you look at the original, you're probably thinking, oh, well, let me just set all of these equal to 0. But really, these two are repeats, right? So if we look at the version where we put everything together into one fraction, we only have these two pieces to worry about. So this one, the nice thing about this one is that it's its own thing. We don't even have to do any work to solve that one because x just equals 0. So here, when we solve this one, we get x equals negative 1. So this tells us that our excluded values are 0 and negative 1. Okay, we didn't bother with excluded values in the previous problems because I didn't want to, the focus was just the adding process, but I want to start bringing in the excluded values here. All right, on to one more example, and this one's even more involved, but again, same idea. So here we have two fractions that have completely different denominators. We have an x minus 2 and an x plus 3. So what I want you to notice is that it's actually a lot like this problem that we did right over here, where we had to multiply both fractions by something to get the denominator to be the same. Here, we do the same exact thing. When we're looking at the left side fraction, all we need to do is multiply the top and bottom by the bottom of the other fraction. So I'm going to go ahead and multiply this one by x plus 3. And I got that from here. Okay, and just like that, we're going to use the other denominator and multiply the right side fraction by it. Remember to do the same thing to the top and bottom always. So once we set it up like this, let's go ahead and see what we are working with here. We have on the left 5 times x plus 3 over our common denominator of x plus 3 times x minus 2. And then we'll have minus. On the right side, we've got 4 times x minus 2. That's weird, 4. 4 times x minus 2 over x plus 3 times x minus 2. Alright, so now that we have achieved our common denominators, just like with addition, we can go ahead and put this all into one fraction and subtract the tops, the numerators. So now we have 5 times x minus 3 minus 4 times x minus 2. All I did was I put these together and included the subtraction. And on the bottom, we just need one of the denominators. All right, so now we're almost done. We're getting there, but we need to do a lot of simplifying on the top. We can distribute the 5 into these parentheses, and we have to distribute the negative 4 into these parentheses. So here, that's going to give us 5 times x, which is 5x, 5 times negative 3, which is negative 15. And then here, we have negative 4 times x, which is negative 4x. Negative 4 times negative 2 is positive 8. All right, we are making progress. We are almost there. Okay, just one last piece of simplifying, because we can combine the 5x and the 4x, well, negative 4x I should say, and we can also combine the negative 15 and the 8. Okay, so let's go ahead and do that. So the 5x minus 4x, that's going to give us a 1x, because 5 minus 4 is 1. Negative 15 plus 8 is going to give us negative 7. All right, and then we will end up on the bottom with the same denominator that we've been having for a while now, which is the common denominator that we chose. And this is going to be our final simplified answer. For excluded values, remember we just have to take the factors from the bottom that are in the common denominator and set them each equal to 0. So do that, and do this. So when you solve this one and subtract 3 from both sides, we get an answer of negative 3. When you solve this one and add 2 to both sides, you get an answer of 2. So my excluded values then are negative 3 and 2. Wow. All right, that is all for today. Hopefully you guys are doing okay with the practice problems. And if you need any help, feel free to let me know. I just really need to fix this little thing here. All right. See you guys next time.